All right, so what we're going to look at right now is going to be that concept practice that you got with the sub yesterday. If you don't have a copy right now, there are extras at the back of the room on the table, okay? And that goes for period 9 too. So first question, taking a look at the inverse. So we want the inverse of f of x is equal to 4x minus 5. So what is the first thing that I do? Any ideas? Change the variables. So I might put first y equals 4x minus 5, and then what? Switch x and y. Right? X is equal to 4y minus 5. We good? Can you guys turn the lights off? I don't think it's showing up real well on the screen up here. Okay. All right. Oh, that's much better. Do another one. Ooh, that's perfect. Okay. All right, so we have x equals 4y minus 5. Whoa. Whoa, too much, too much. All right, x equals 4y minus 5. So I've switched x and y. I want to get y by itself, correct? Okay, so I'm going to add 5. X plus 5 is equal to 4y, and then what do I need to do? Divide by 4. Now, be very careful here. A lot of people forget that you're dividing the whole thing by 4. Make sure it's the x and the plus 5 that get divided by 4. Is everybody clear on that? Okay, so x plus 5 divided by 4. And instead of writing y, I'm going to put f inverse of x. Okay, just to represent that this is the inverse function of my original. This is the most sophisticated thing they could ever ask you for, so I'm going to ask you to shoot for that, because that's like the gold standard, if you will, for answering these questions. Okay. Cool? How'd I get the 4? Here? It's in the original.
Because that's what happens when in an inverse situation. You switch the opposite.
Yeah, I need to get y by itself, Felipe. So an inverse is the switch of x and y. So then I just need to get y by itself so it's graphable. Okay? Any questions on number 1? Okay. Number 2, you have an exponential equation. 256 equals 4 times 2 to the x. Okay, we want an expression using only log, no decimals, that could be used to solve for x. So 256 equals 4 times 2 to the x. Now, my goal is to get x by itself, right? So I'm going to basically try to slowly undo things to get to that point. Okay? Now this 4 is not attached to the x or to the base. Totally going to divide by the 4. Anytime you can divide out first, you should. And one of the things that I saw students mess up a lot in previous test questions is that it was like a minus, they'd start adding or subtracting that coefficient. Pay really close attention to if it's multiplied, because then the only correct thing to do would be to divide. Okay? All right. So I need 256 divided by 4. What is that? 64. Okay. So 64 is equal to 2 to the x. I could do that. That's one way I could solve this. But they want me to express it in logs. Okay? So I'm going to take log base 2 of both sides. Is that okay? Right? Because log base 2 is the inverse of 2 to the x. So I have log base 2 of 64 is equal to x. Now, typically when they're asking you for this, they're going to make you use the change of base formula. Do we remember what that is?
Yes.
Okay, so what is that for this?
That is where you put in log 10 of 64 divided by log 10 of 2.
Okay. This is the form that they are going to ask you about on your unit test. Okay? They are going to ask you to express it with the change of base formula.
The base goes in the bottom and
Right, the base goes in the bottom, the value goes in the top. Okay? Yep.
Yes.
Well, for here. Here, if I have no base written, it's assumed to be a what? A 10. Okay? Questions on this? Log base 2. So I use log base 2 on purpose because Log base 2 and 2 to the x are inverses, and they will undo each other. Okay, so that was a strategic move. Another way that you could think about it is this guy right over here. Okay, if you take a look, oh, here we go. Right, this poster right over here is another way to be thinking about it. Okay, I could just make the conversion based upon this. Okay? Questions on number 2? Yeah, it's following me. Okay. All right, what about number 3? We ready to do that? Yes, Miss Jungle, can't wait. Okay, great. So, we've got population of Canada in 2000 was 31 million, and in 2015 it was 36 million. We want to know, let's see, we have the equation. We want to know the growth rate that represents the change in population. Okay, so we're going to put everything in for different places. Yeah, okay, just trust me. So A is always the amount, P is what I start with, R is the rate, and T is the time. Okay, now what am I solving for in this problem? I'm solving for the rate. So I know I do not have R. Okay, I don't know that. So that means they had to give me everything else. Okay, now what is the population that I start with? In 2000 I have what? 31 million. Okay, so P is 31. P is your starting point. I know that I don't have R. Do I have time?
Yes.
What is the time?
Time is
15 years. I'm not going to put in 2015. I'm not going to put in 2000. I'm going to put in 15 because that's the amount of time that has passed since the original amount. Does that make sense? Okay. All right, and then what is that amount 15 years later? 36 million. Okay. We okay with the setup? Okay. Can you give me a calculator real quick? So what's the first thing I'm going to do here?
5, 36 by 31.
Right, and we notice that this pops up a lot in these exponential equations where I have this lingering coefficient that I'm going to need to divide first. Does that make sense?
Also, could you write 31 is 31 to the 6th?
Huh?
Or 31 10 to the 6th because there's 10 zeros or 6 zeros following after?
No.
There's not even.
No, I'm just going to do this. So 36 divided by 31. I'm going to leave it as a fraction right now just to make sure I don't mess it up. Okay, I'm going to wait to put it into a decimal until the very end. Does that make sense? Okay, the reason why we use fractions is because they're more precise. Right? Decimals, if we round them, can give us things that are a little bit off. So I'm going to leave it as a fraction for as long as I can. So 36 over 31 is equal to 1 plus r to the 15 power. How do I get to r now? What's in the way?
You have to get rid of the power.
I have to get rid of that 15 power, right? So what do I do to both sides to get rid of that?
15th power.
I'm going to apply the 1/15th power. Okay, so how I'm going to do this in my calculator is I'm going to use my alpha y equals fraction bar to put 36 over 31 to the 1 over 15 power. So for those of you looking here, it should look something like that. Maybe it's backwards. I don't know. Okay, but 36 over 31 to the 1 over 15 power. All right, and what do I get? 1.010018, right? And then it keeps going. 636 is what I see, is equal to 1 plus r. Correct? Everybody okay with that? You okay with that, Raquel? Okay. So then I'm going to subtract 1 on both sides. I get 0.01. Are we okay rounding it to 0.01? Yes? All this is like all crazy decimals that come afterwards. I'm going to round it to 0.01. You could say 0.10 or 0.10, but there's another 0 afterwards. Like, I'm just going to go 0.01. Is that okay? Okay, and so that is equal to my rate. So if I'm going to answer this question, right, the growth rate that represents the change in population is r is equal to 0.01, or you could write 1%. Okay. Questions on this? Was that helpful? Okay. All right, ready for number 4? So you can say yes, it's okay. We're ready for number 4? Okay, so we have a company's cell phone production can be represented by that particular equation. Y is equal to 2 times 3 to the x over 2 power. X represents the number of years since 2000. So anytime you get these problems with the time, make note of what x represents, right? Number of years since when, okay? And then what year did the company produce approximately 100,000 cell phones, okay? So notice Y. Does everybody see how Y says in thousands of cell phones? Does everybody see that in the problem? Okay? So that means I want Y to be 100. Is everybody clear on that? Okay? So I want to know 100 is equal to 2 times 3 to the x over 2 power. Okay, I want to know what year this happens. Questions on my setup? Okay, so again, what are we noticing with these exponential equations? It's got a what? That multiplication, that coefficient, right? So I'm going to divide both sides by 2. So 50 is equal to 3 to the x over 2. Now what? Okay. What's the only thing standing in my way to get to this base? Or the exponent, right? Like, this is all locked together, right? I basically have to make it fall apart before I can get to the x. Okay? So we can either use, right, this rule over here that we have on the poster, right? Or we can use the inverse function. Does that make sense? So what's the inverse of a base 3? Log base 3. Everybody okay with that? So this becomes log base 3 of 50 is equal to what? X over 2. Okay? And then what do I need to do last to get x by itself? Multiply by 2. Good. Multiply both sides by 2. So I should put in 2 log base 3 of 50 into my calculator. Okay? So I should see you practicing that. I'm going to go ahead and put this in the calculator. Remember, it's math, and then you scroll down to A. So math A, you're going to see that log base option. Okay? So log base 3 of 50 times 2 is going to be, what, 7 point something? Yeah, 7.122. Okay, now what does that mean? Let's look back at the problem. Okay? What year did the company produce that many cell phones? So what is the year? Is it the year 7? So I add 7 to the initial year. The initial year here is 2000. So that means the company is going to reach, right? The company will make 100,000 cell phones in 2007. Fair enough? Because I just add something. Now, Miss, what do I do about this decimal? Right? Do these decimal parts afterwards matter? Well, if it's January 2007 or March 2007, are we still 2007? Yes. Okay. Does that make sense? Okay, they're only asking me for the year, not the month, so it's still within the realm of 2007. Last one? Ready for the last one? Okay. All right, so we have an investment of $2,000 at 3% interest compounded annually. We have an equation to work with. They want to know how long will it take her investment to double. Okay, so we're going back. This equation right here is going to keep coming up over and over and over and over again. This A equals P times 1 plus R to the T power. Okay. Now, if I take a look at Jenny, we want to know what? The time, right? So that means they have to give me all the other pieces of information. Well, what's the original amount that Jenny has? 2,000. Okay, how do I write the rate? 1 plus, what's 3%? So I do 1 plus 0.03. I do not know the time. Do I know what amount we're shooting for? 3,000, 4,000? It's okay, so it's doubled, so that means that we want to know when Jenny has $4,000. Okay? Does this look like every other exponential equation we've been solving so far? Yeah, totally, right? So I'm going to do what first? Right, divide by that coefficient. Right, divide by 2,000, so that means I get 2 is equal to, can I write this as 1.03 now? Is everybody okay with that? Right, I just did the 1 plus 0.03 to the t power. So, where is the variable I want? It's up here in the exponent, right? How do I get to it? Okay, I can use log. So remember, we can use this guy over here, the poster. We can use these formulas right here. Or we can apply the inverse function. Okay? So, what would the inverse function be? Log base 1.03. Okay? So log base 1.03. Or again, you can use what's up on the poster. So I have log base 1.03 of 2 is equal to t. Okay. So I'm going to go ahead and do that. Remember, it's math A. Log base 1.03 of 2. So I get 23.449772225. I'm just writing it all out because apparently I feel like doing that. Okay. Now, let's go ahead and take a look at what they're asking, right? I want to make sure, are they asking me for a particular year? Are they asking me for just how long, right? So approximately how long will it take for her investment to double? Okay. Well, if it's only compounded annually, does it compound halfway through the year? No, it does not. Does everybody see that? You guys know what I'm saying? Like, if I compound it, let's say every year on January 1st, that's when I compound my interest, right? Well, is there such thing as increasing my amount like halfway through the year?
Yes.
For an annual interest rate? But it's, but not for this problem,
Oh, yeah.
right? This is only done annually. So at 23 years, will Jenny have double? No. So I have to wait until year 24 to know that Jenny has doubled her money, right? So if I were to write this out, it will take 24 years for Jenny to double her investment. Okay. Does that make sense? Okay, yeah, Miguel.
What happened to the, wasn't it supposed to be 2,000?
For this problem in particular, no.
No, like when you divide by 2,000 on the website.
Yeah, 4,000 divided by 2,000 is 2.
Oh, yeah.
Right? Sound good? All right, any other questions on this problem? So the 24 versus the 23 point something makes sense? Right, since I'm not compounding until every year, I'm not going to be able to have double that money. Okay? All right, well, these are all the problems. So Mr. Murray actually put this together as a good practice for your quiz tomorrow. I'm going to strongly recommend that you go through this and the similar practice problems on your unit study guide before tomorrow. Okay? Any other questions? All right, and just as a reminder for homework, you have that list on the bottom of your gold sheet. You're going to need worksheets 5.1 through 5.6. And one of the big ones that I think a lot of students have not yet picked up are those exponential word problems. So make sure you grab that worksheet on the back table if you don't have it already. That's going to be due this Friday, which is the same day as your unit test. Okay, so just as review, quiz tomorrow, test Friday. All your homework for this unit is due on Friday. Do not forget 5-6 and the exponential word problems worksheet. All right, good luck.